Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 68, I chat with Jeff Murray, president of SpectraCal, about TV calibration. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by Cachefly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded June 6th, 2011. Episode 68, SpectraCalifragilisticexpialidocious. This episode of Home Theater Geeks is brought to you by Netflix. Watch thousands of TV episodes and movies streamed to your PC, Mac, or TV instantly. Plus, get DVDs and Blu-rays by mail in about one business day. For your free 30-day trial, go to netflix.com/twit. And by hover.com, domain name registration and management that's simple. For Hover's transfer concierge service, free for our audience, go to hover.com/HTG, offer code HTG. Hey there, Scott Wilkinson here with UltimateAVMag.com and HomeTheater.com. This week's guest geek is Jeff Murray, president of SpectraCal, makers of one of the most common and widely used TV calibration systems that I know of anyway. And so we're going to be talking about TV calibration. Hey, Jeff, welcome to the show.
Hey, Scott. Good to talk to you again, and
Yes.
Really happy to be here.
Thank you so much. Those of you who are tuned into the live video stream at live.twit.tv or signed into the chat room at irc.twit.tv can post questions for Jeff, and I'll pass on as many as I can. So, Jeff, you're the president of SpectraCal, makers of CalMan software, which I've used some and look forward to using more. And so give us a little bit of an idea of how SpectraCal got started. What are the goals of the company?
Well, SpectraCal got started by L.A. Heberlein and Derek Smith back about 5 years ago, and Derek was a hobbyist, and he wanted to make some software for calibrating his own TV set, and that was kind of the start. And he has a very strong background in programming, as does L.A. So that was the early CalMan, which was basically a Excel spreadsheet with some macros, and then now it's grown into a full-blown program that addresses several markets, including home theater and digital cinema. Mm-hmm. And so now we're at about 5.5 to 6 years into it, all told, and so we think the product has matured to a point where we're addressing, and I know it's some of the things we'll talk about today, but we're addressing things like the color management system, like multi-point grayscale. So we're trying to, at this point, get to the point where we can do things through our software directly to the television or display and or the meter. So that's kind of what we're all about.
Mm-hmm. Now, recently, you've been involved in software for a long time, but recently you also started doing a little bit with hardware, haven't you?
Yes, we do, and we do a new video generator that is called the AV Foundry Video Forge. It does your digital HDMI test patterns, almost any flavor, 3D, left eye, right eye, top, bottom. It's very configurable, works with our software, of course. It's a good reference source. And then, of course, we represent all of the different pieces of hardware, video processors, like Konica Minolta, Klein, X-Rite. We represent all of those type of products also, since we talk to them. And so we have to work closely with the developers on those different teams to make everything kind of work seamlessly for the custom integrator out there, all the way down to, with our DIY version, even a consumer or prosumer who would actually calibrate their own TV.
Right. And just for those who might not be familiar with those names, Konica Minolta, Klein, what was the other one you mentioned? X-Rite.
X-Rite.
Make what are sometimes called colorimeters, instruments, measurement instruments that measure the color points and the grayscale of a video display and send that information to CalMan, the software that you make, so that it can tell you, oh, the green is off or the blue is off or the grayscale is off, and here's how you should fix it. So that is one piece of hardware that is required of anyone who wants to go beyond the basic picture controls of brightness, contrast, color, tint, and sharpness, which you can set without these instruments. But if you want to go beyond that and actually do what's called a grayscale calibration or a colorimetry calibration, which we'll talk about in a bit, then you need some of these instruments, one of these instruments anyway, and CalMan. Now, these instruments can be pretty expensive, can't they?
Yes, and here's a kind of a way to think of it, because they run the gamut from something that a consumer could use in their home, from anywhere from the $200 or $300 range up to up in the $40,000, $50,000, $60,000, which would be used in a laboratory or by a television manufacturer, monitor manufacturer. But the way to think of it is like this: is what drives cost or price on this type of an instrument is how far they can measure into black and how fast they can take those measurements. And if you think about even how TVs are rated out there, is everybody talks about black level and having a good dark black, and a meter that can read down into black is going to be very expensive. But that's what you need to do for the most part, because that's where the eye sees the most changes or differences or problems are down in that dark black part of the picture. So it's kind of a good general synopsis of how you kind of price meters out from the bottom to the top, and it's really based on application, very much so. Yeah.
So here's a comment in the chat room from The Undecided. He says, wait, there's a DIY way to calibrate? and there is. You don't need to spend a ton of money,
right,
in order to do it yourself at home. I would say the more important thing is you need to be educated.
I would agree with that 110%. So, that's one thing I didn't talk about is, one of the things my company does is we do a lot of training all over the country and internationally. We train people who are a lot of professional calibrators, but also people who want to learn about it. And if you think about it, and there's different levels of calibration, like Scott said. But if you look at the one he mentioned, black level, white level, or brightness and contrast, color, tint, and sharpness. Color and tint you can do with the little blue filters that come with a lot of these different test discs. If you do that correct, and that's all visual, you're going to get about a 75% improvement in the picture produced by that display. So because you're in effect setting the dynamic range, you move up to grayscale where you need test equipment, you need a way to measure. You're going to get another 20% out of that by being able to do a complete good flat grayscale like you would see printed in the magazines, the before calibration, after calibration. It's the typical snapshot. And then beyond that, if the display is capable of it, you can do some minor adjustments to the CMS or the color space, if you will.
It's CMS, by the way, stands for Color Management System, which more and more TVs are offering these days. But I would say that's at least as dangerous to go in and fiddle with as grayscale, wouldn't you?
If you, unless you're a TV repairman who has to go out and fix it.
Yeah, right. Well, if you're a professional technician, that's one thing.
Yeah.
But if you're a DIYer at home, that might be something else.
I would say that, since this is so new to being available in the different displays out there, I would say that unless, and I know we're going to talk about this a little bit more in depth, hopefully a little bit later on, but I would say unless they have a fully implemented CMS system with controls and you have a very accurate meter and you have a measurement tool like a CalMan that can actually get you the data that you need, then I would say don't touch it. For the most part, you're going to get diminishing returns. I was talking to somebody last week about the Pioneer Kuro when it came out, and the CMS, if you touched it in any way, shape, or form, you made a worse picture. If you got the grayscale flat, you had a beautiful picture with great dynamic range, and you should just leave it at that.
Right. SoCal Ray Jr. in the chat room says most CMS systems don't work correctly, and I'd have to agree. In my experience, even when I get them so that they measure correctly, the picture that I end up with looks far worse. So I end up turning it off.
Yep, that's very true, and the reason for that is essentially. In order to properly implement CMS, you need X, Y, and big Y luminance control for all the primary and secondary colors.
Now, let's first of all make sure everyone understands that.
Okay.
All the colors that you can see on a TV can be represented in a two-dimensional graph with an X coordinate and a Y coordinate. Those of you who might remember a little bit of high school math might remember X and Y coordinates. Oh, Jeff, you're holding up the...
Yeah, I brought a diagram with me.
Oh, fantastic.
Actually.
This is called the CIE diagram, and it shows you all the colors that a TV can represent. In fact, it shows you all the colors that we can see as human beings. There it is right there.
Right.
And within it is a triangle. And the triangle is defined by 3 points, each with an X and a Y coordinate. And one of those points is for green, one is for red, one is for blue. And so, Jeff, what you're talking about here with the X and Y coordinates is where is that green point on that chart? Where is the red point? Where is the blue point? And then big Y is otherwise known as luminance. It's brightness. It's how bright the picture is, and the color is, and it can go from being totally gone, very dark, to maximum brightness. That's
correct. So if you really wanted to do CMS correctly, even the way we do it, and even the sets where I've seen it implemented correctly, you still have to pick a point, and then you have to deal with in other words, 70%. So I'm going to calculate what all of my targets are for green luminance, red luminance, blue luminance, but then I'm going to do my measurements based on maybe 70% white or 70 IRE. And if you think about it, there's many, many more levels of light for blue and red and green, something where you almost need to do what I would call a sweep, where you would look at maybe 1,024 shades of blue, and then those should track. It's exactly like grayscale, which is the combination of the three
primary colors, yeah.
Yeah, it's the same concept for actually being able to adjust the CMS, and that's where you start getting the goofy result. In other words, what Scott's saying is you have this target point for this Rec 709, which is the target triangle for HD TV.
Yep.
And you get that X and Y, and you get the little circle in the dot for green, and then all of a sudden you go and look at the picture and everything looks like a Martian. Or and you're saying, well, what the heck did I do wrong? Well, first off, the main caveat is CalMan is a measurement tool. So
Yes.
CalMan didn't break your TV set.
Right. And you can always, reset those controls. Almost all
Absolutely.
TVs have a reset button,
Yeah.
essentially, a control in the menu that says reset.
Yeah.
And you can go back to factory defaults and you're no harm, no foul.
Mm-hmm. And I think that's why they're adding the factory resets now so heavily, because it's kind of the story I hear in a lot of the ISF seminars is they never take a control off a TV or an on-screen display. They just add.
Right.
So, as things are not needed anymore, they just keep adding them on top and so on. But yeah,
kind
you
of
can
a drag, in my opinion, because it makes the menu so unwieldy and so massive. People just get confused and throw up their hands.
Well, and that's where a lot of the professional calibrators come in, is they study these TVs. So when they go out, and that's part of the work. I mean, part of the work is calibrating, but if you think about it, it's part of the work is also just demystifying what do all these things do, because somebody's got to go in there and play with them and see what does this do and what does that do, and the customer does want to know. The person who made the investment in the new big screen TV, they want to know what that can do for them and if it can enhance the experience. So
yeah, exactly.
But it's tough.
It is tough. But that brings up a good point about education, which is you've said that SpectraCal offers courses, training around the country and elsewhere, I'm sure, in the world. ISF, the Imaging Science Foundation, Joel Silver's organization, he's been on the show, offers training courses. THX offers training courses. And really, if somebody wants to get into this deeply and do it well, they really need some pretty serious education in order to know what the controls do and how to use them and which ones maybe to avoid even.
I would agree with that 110%. In fact, I teach a lot of the classes. I taught a lot of them last year. We did every Major League Baseball city in America last summer, and
wow, that's kind of an interesting subset, isn't it?
Yeah, I mean, that was kind of like, well, why not? They got to be fairly decent sized cities, and but anyway, what I always tell people in calibrating is you're not going to have as much trouble calibrating as you are learning that display or projector. So you're very right. I mean, it is what we've done in our training classes now is we try to use common fixed models that we use over and over and over, because since we're doing this in the field in a day, we don't have the time to spend half a day learning the display and learning what's implemented properly and what's not, and if the CMS works or if it doesn't. We have a known quantity that makes it easier for learning, and then we put the caveat in there that, okay, the biggest challenge you're going to have is figuring out what to adjust and what not to touch.
Right.
And I think that's where the training comes in. It's just it's like it's common sense kind of after you kind of learn the basics.
Now, SoCal Ray Jr. in the chat room points out that the AV, you mentioned the Video Forge before, which is a test pattern generator, and I want to talk about that in a minute. But there's also another device from the same company called Video EQ, which actually provides a good CMS, which can be applied to any TV.
That is very true. It's a 1024-bit. I will call it a graphic equalizer for video. So, and it actually is auto-calibratable via the CalMan software. And the thing we found for the home user with the product this is a great product. It's a phenomenal product. It's one HDMI in, one HDMI out, and we take the source or the generator, and we can basically manipulate 1,024 points of gray. So, and we can manipulate the CMS primary and secondary color. So yeah, if you put this in line with the TV,
between the source and the TV.
Correct. That's where you'd put it. So you would probably end up putting this thing. And I'm trying to think of some connectivity. You know, when you talk about a switching receiver, you would want this on the source that was most important to you, or you would want this being able to be switched into. So you could use some of the different memories and maybe get a couple different sources, like a set-top box or a Blu-ray player. Mm-hmm. The one downside for a consumer is the box at this point is still a little bit pricey for the average consumer, because I think we're talking about $1,200 for this box, and so it's found a lot more homes in post-production where they actually make movies and they have to screen dailies, and you're talking about a factor of, you know, 10x, 20x on the projectors these things are running on. So they would be in like a Titan, you know, a DP or
a digital projection Titan is I believe, on the order of like a $30,000 projector.
Yes.
So that's pretty expensive. That's not going to be in most people's homes.
Panasonic DILAs.
Panasonic makes
JVCs.
JVC DILAs. Yeah.
Yeah. Yeah. And you know, you know, I have one in my home too.
Well, you have easy access.
But I got everything in my home.
Yeah, right, exactly. That actually brings up another.
I have a $1,200 processor on my $2,000 TV, and so anyway.
Yeah, exactly. Exactly.
It does correct all problems, though, and they will come down over time. It's just all about the technology. It's fantastic amount of math that's being done in this little box on this FPGA that you know, you're probably not going to see that level of capability built into a display or projector soon, because it's a lot of coding, a lot of math, a lot of different algorithms, and a lot of time spent by the programmers to get that thing working right. So.
It brings up, though, an interesting point. You mentioned that SpectraCal will talk with the video EQ, and you can sort of automate the process. And you've also recently announced a version of the CalMan software that will do that with the latest version, the 2011, some of the 2011 models of Panasonic plasmas. Tell us a little bit about that.
Well, the Panasonic VT, DT, and CT series, I believe. It's the plasmas.
They're the ST is the lowest cost, GT30, ST30, GT30, and VT30 is the top of the line.
And the VT30 is the 55 and 65 inch PDP, I believe.
Correct. They're all plasmas, right?
Okay. There's a DT in there too, isn't there? That's an LCD.
Oh yes, a DT that's an LCD. Correct. Yeah. Only goes up to 37 inches, I believe.
Yeah. So we can calibrate all of the two. You know, and I should have written some notes down. We do the VT30, and I know we do the DT, and I think it's the GT of the 2011 models. And what we do there is we connect in through the VRNet on the Panasonic. They have a Ethernet port, so we can connect directly into that, or we can connect through the home Wi-Fi network if they're connected that way. And we can basically take control of that TV's ISF day and night mode and take all the measurements. We can write back to multi-point grayscale. We can write back to this automatically and end up getting a very, very flat, like, and I know you're familiar with the term, but you can, I've seen the VT30 go down to less than 0.5 delta error, top to bottom, in about 5 minutes. So
this is quite amazing. Just for those who don't know, delta error, or delta E as we often call it, is how much is the gray, the color of gray, white, gray, or black at different levels, how accurate is it or how inaccurate is it? The lower the delta E number, the more accurate the picture is. And we typically want the delta E number to be below 3 or 4. And below 3 or 4, you really, the human eye can't really distinguish the difference. And you're saying you're getting delta E below 0.5, which is absurdly low.
Yeah, it's fantastic, and obviously to get those kind of results, we're seeing that with a Konica Minolta or a Klein K10 that does very good into deep black, and they're very fast. Yeah, we're seeing that as a result.
But if an owner of a new Panasonic TV wants to do this, they need to get a copy of CalMan. They need to get a measurement instrument such as the ones we've been talking about, and you can get them for as little as you said, $200 or $300, but that's a relatively, it's not as accurate, shall we say, as the more expensive ones. You know, for the case of a TV that you're going to do it once maybe, or once a year or 2 years just to touch it up, maybe that's good enough. Which brings up a bunch of stuff, and we got a lot of questions in the chat room too. So we're going to get to a lot of those in just a moment, but if you'll bear with me just for a second, I'd like to take a moment and thank the sponsor, one of the sponsors for this episode of Home Theater Geeks, which is Netflix. Netflix delivers movies directly to your home, and that saves you time, money, and hassle, that's for sure. You can instantly watch thousands of TV episodes and movies, stream directly to your PC or Mac, or stream to your TV or Blu-ray player or Roku box or any of a number of devices that are Netflix ready, even game consoles, Xbox 360, PS3, Nintendo Wii. Plus, if you're of the hardware disc kind of persuasion, you can get DVDs and Blu-rays by mail in about 1 business day. You can watch as many movies as you want, anytime you want. There are never any late fees or due dates. We always like to recommend a Netflix streaming pick of the week. And one of the things that are available, the TV shows actually that are available for streaming on Netflix, is Mind Freak. I don't know if you've seen this or not. It stars magician Chris Angel, who is definitely a mind freak. Some of the stuff he does, you just cannot believe. There are plenty of magicians out there. I love Penn and Teller and a bunch of other magicians. Some of the ones in Vegas are quite remarkable. But this guy, Chris Angel, is really remarkable. I saw him walk up the side of the Luxor one time. And you know, how can you imagine? That can't be done. Some of the stuff he does gets a little yucky, but the stuff, his levitation stuff, is amazing. So I highly recommend this this TV show. He's done it for like 6 seasons now on A&E, and it's available for streaming from Netflix. You can instantly watch this show or choose from thousands of TV episodes and other movies when you register for a free trial membership. Go to netflix.com/twit. Be sure to sign up for that free trial at netflix.com/twit. So, as I said, we have a bunch of questions in the chat room. One of them from L33T, he calls this a left field question, and it really is. How do we calibrate TVs for people with color blindness? Have you ever run across that?
It's an interesting question, and I have run across, let me flip it the other way. In my old company, we did a software for medical, and it was called DICOM software. DICOM Chapter 14, you could Google it, is the grayscale standard for medical imaging, DICOM. Anyway, what we found out when we were in that market, and we're working on CalMan to get back into that market, but what we found out was that they told us the best radiologists out there were actually the ones that were colorblind. So the reason being was because they could discern shades of gray better than a person who could see colors. And there's a pattern in medical called the Briggs pattern, and you could probably Google that too. It's got about a gazillion shades of gray in it, and you got to really look at it closely to see that. So it would just be like calibrating for black and white TV, if you think about it. So you'd want to hit a target of 5450 instead of D65. And I know we haven't really got into the technical yet, But you would still want to be able to provide that customer with a good dynamic range. And so it would there's references built into CalMan. There's references built into almost every software out there that allow you to plug in something that's a little bit warmer, a little bit more towards red, I guess, on that diagram I showed earlier.
Right, and we should point out just real quick for those who might not know, what we're talking about here is, remember on that diagram there were 3 points in a triangle, the green point, the red point, and the blue point. There's also a point in the middle of the triangle which is called the white point, which is the color of white or the color of gray. Now on a TV, that color of gray has a very specific set of XY coordinates, just like the other points, and it's known by a name, and that name is D65. And what, Jeff, what you're talking about for medical imaging, I guess, is a little warmer. It's a color temperature. The D65 color temperature is 6,500. And I don't want to necessarily get into that because that's a whole other can of worms.
No, we don't have to do that today.
But you're talking about a color temperature of like 5,400 degrees or 5,450. Which the bottom line for that is when you look at a white, which is calibrated to that color temperature, it looks a little reddish, just a little pinkish, whereas 6,500 looks less so. To me, it looks that 6,500 looks just plain old white. Interestingly, though, black and white films of yore were calibrated to, I believe it was 5,600 degrees. So they do have a little bit of that sepia tone look to them, as opposed to modern color television. So I just wanted to throw that in there. And I'm interested that medical imaging actually uses a warmer color temperature.
Well, let's kind of flip back. All right. So what medical imaging is trying to do, most of your radiological displays, which are used to look at X-rays, are they're monochrome monitors anyway. I mean, they're
true enough.
And so what you're looking at, what our product would do, would be for what's called a secondary viewing station, which would be the doctor's home computer, which would be a color monitor, typical off-the-shelf high-end video card. Well, we would go in and make that color monitor into a monitor that would do monochrome or would do a good grayscale, because they wouldn't be looking at colors. They would only be looking at a digital X-ray.
Right.
And the way to get a better dynamic range and the way to pick out, if you think about it, what you're going to use that for is to make diagnosis. So you're looking at, a compound fracture, misadjusted, too much contrast, you probably still see the break. But cancer or a lesion, where you really have to kind of investigate and look at that image from an X-ray or CT or whatever the source device is, then it becomes more critical to get a good diagnosis. So what the doc is looking at and how it's calibrated in that application is extremely critical.
Oh, no kidding. It does bring up another question, though, which is, and I think I saw it in the chat room earlier, is calibrating a computer monitor different than calibrating a television?
It is. It's actually a computer monitor, which is typically used for data, is calibrated a little bit cooler. So 9,300. So instead of going towards the red on the diagram, our little trusty diagram here, instead of going towards red. Oops, wrong way. Red here.
Oh, look, there's another one right there.
Oh, he got one. Okay. So instead of going towards red, and this one doesn't have a black body curve on it, but if you can see where the white is in the middle.
Area is, yeah.
Yeah. So that white area in the middle, if I kind of shift down towards blue, that would be a higher correlated color temperature. If I shift it over towards red, that would be a lower correlated color temperature.
And what you're saying is computer monitors, you tend to want them to move more towards blue a little bit and less so for TVs.
Exactly. Well, and the computer monitor is typically used for data, PowerPoint,
Right.
Word documents. So if you even look at
of course, these days, pardon me for interrupting, but these days, as I just mentioned with Netflix, people are starting to watch more movies and TV shows and so on their computer monitors. So that seems to me it could be a problem. You want it to be set up one way for data and a different way for watching TV and movies.
And that's absolutely true. And people, even like myself, I set my computer monitor up at 6500 just because I'm used to it. And I don't mess with the 9300 because it's too hard on my eyes. It's like the vivid mode on a TV or the store demo mode on a TV.
Right.
So do you calibrate them differently? Let's think about the signal path. And you're right about the Netflix thing. I think you would have two memories set. So you'd have one for data, one for D65, maybe one for day viewing, night viewing. We could talk about that a little later. But the thing about the computer is you have a video card in the path. And then you have some control inside the monitor itself. And in computerese, they use what's called a LUT, or a LUT, a lookup table, where they can store the data that tells where things go as far as adjustments on, if you say your D point is 6500 or D65, that's 313329 on that chart I showed on X and Y.
Those are the X and Y coordinates, 313 and 329.
Right. And I want those to line up at 313329 from 10% white, which is almost black, up to 100% white, which is pure white.
Right.
And so in computers, you could do that through the video card because it's always going to be in the signal path. And you could do some limited stuff through the monitor. With our new product, CalPC, which we just came out with about 3 or 4 months ago, you could do this through the DDC channel in the computer monitor and the computer video card. And what that means, that's direct display control. That means that you run this CalPC software, and it goes out, and it's just like if you think about if you do extended display or duplicate display on a monitor, that setup, if you right-click in Windows 7, we kind of access through that same type of a port, and we can go in and do a 10-point grayscale. We can do automatic black level, automatic white level, and we can write a LUT and an ICC profile that could then be used by things like Photoshop or Illustrator or anything like that. So we can pretty much do anything that's been produced in the last 2 years in a computer monitor and a computer video card. We can do that automatically. You just need a meter, obviously, and you need CalMan or CalPC, and you could do all your monitors.
Now, Socrates Johnson asks a related question in the chat room about computers. How does using a pattern generator on a laptop using HDMI output compare to a dedicated pattern generator?
That's a very common question. If you think about it, okay, so if my laptop is my only source to the monitor, and it's always through that HDMI cable, and I'm never going to have anything else, no sources or anything in there, that could be an okay situation. The problem with it is you're inducing into the signal path an unknown quantity, i.e. the computer's video card, the PC video card. What happens when you use a professional test pattern generator is you actually render patterns based on the SMPTE specs and the SMPTE standards that are rendered on the fly and hit the perfect levels every time. So you're starting with a known good entity, and anybody who's kind of troubleshot systems for a while knows that having a known good quantity at the front of the food chain regardless of where there's at, because, you know, we have systems in places where there's, you know, Xbox, there's a couple satellite set-top boxes, cable, off-air feed, Blu-ray player. All this stuff goes into a rack, gets distributed throughout the house.
Or even if it just gets connected to an AV receiver and sent to one TV. All of these sources have different characteristics.
They all have the potential to screw things up. And that's why I went back and I said, if it's only going to be the laptop through one HDMI cable and it's always to the same panel, and that's the known way that thing is going to be installed from, you know, for the next 5 years, then you're fine. In fact, I'd set my black level and white level that way if that's the connection, but that's not probably a typical system.
Right. Which is why, in fact, many calibrators and reviewers don't use a pattern generator, because you're not going to end up watching a pattern generator on your TV when you're watching TV or a movie. They calibrate using test discs from the Blu-ray player that they're actually going to use to watch the content.
Yeah. Well, I will just clarify one thing. There are some of us that do like to watch test patterns.
Yeah. Yeah, I know. And you're not alone there. There are some of us who do. That's true. But eventually we're going to end up watching a movie at some point. Now, that brings up another question, a real problem, which is, how do you calibrate the TV for a broadcast source, like over the air or cable or satellite? Those things typically don't have calibration patterns in them, so you can't actually calibrate for those kinds of sources, except, for example, HDNet broadcasts a few barely useful test patterns, like at 2 o'clock in the morning every couple of weeks. And so if you DVR that, if you record that, you can use that sort of. I know that at least one TiVo model, the Premier, I think, has THX Optimizer built in, which does give you useful test patterns to calibrate for that source. So there are certain things you can do, but in many cases, there's nothing you can do, is there?
Well, in the case of a set-top box, what I would do is I would definitely calibrate that path with a generator. So I'm coming out of my set-top box into my AVR, into my, in my case, I have a Radiance XE video processor, which, you know, and then at least I would see, then I can plug the set-top box back in, and I can see if there's any major variants or major things that I'm seeing through picture. HDNet's a perfect example. I can look at their test patterns, but I can also look at some very bright scenes in movies, very dark scene type movies. But you're right. I mean, they don't allow, there's no input on the set-top box, so you have no way to get through it. But you can sometimes, like the Radiance XD has input memories that are based on resolutions. So if you can kind of get a fix on what is actually happening with the set-top box as, you know, ESPN changes from day to night to major sporting event, you can actually tweak a little bit of that, and mostly by eye, but you can actually fix some of that.
Yeah.
But doing, you know, that's a place where a generator's critical. I mean,
yes, absolutely. It's really the only choice you have, and the best way to get a baseline. And then,
that's right.
And then I guess you tweak to taste according to what you see on with real content.
You need to know where you're at.
Yeah,
absolutely.
Exactly.
You need to get a baseline.
We've got a bunch more questions in the chat room and not much more time, so I do want to take one more moment to thank our other sponsor for this episode, Hover.com. Hover is all about making domain registration and service simple. They don't sell a ton of services. They focus on making it easy to register and manage domains and email. And they have a new no-hold policy for customer service Monday through Friday, 9 to 9 Eastern Time. When you call, you're going to get a live person. They're not going to put you on hold. How's that for customer service? I don't think it's very common at all these days. And here's an exclusive offer for the TWiT audience, a free transfer concierge service. Hover is offering TWiT audience members free domain transfer no matter how many domain names they have. It's a $25 service on the site. Just call Hover, give them your username and password, and they'll take it from there. Hover will get the authorization codes, deal with all the emails, let you know when your domain names are on Hover and working exactly as you want them to. The transfer itself is $10 per domain name, and this extends the domain 1 year beyond its current registration date. For the TWiT audience, Hover will handle the whole hassle of transfer for you at no additional cost. To get Hover's free transfer concierge service, call Hover's customer service number listed on their website. And if you need a new domain, get 10% off by going to hover.com/HTG and using the offer code HTG. And we thank Hover for their support of the TWiT network and Home Theater Geeks. Here's a question from Alex Santos in the chat room that I really did want to cover, which I've gotten a lot of this lately. When you buy a brand new TV, the common wisdom is to let it play for a while before you actually calibrate it. I've always said this is more important for plasma than it is for LCD, but correct me if I'm wrong.
No, I think you're right. The plasma uses a SMPTE phosphor, so it's gonna need to kind of age and burn in a little bit. Mm-hmm. Any kind of a bulb type device, projection,
like a projector,
DLP,
yeah.
Right? Mm-hmm. Same thing. Even if I've seen some of the charts on some of the projectors and they show bulb aging rapidly, first 100 hours, changing even towards chromatic aberrations towards red, and they could be calibrated right out, and then after that they're pretty stable for the rest of the life. Mm-hmm. Any calibrator out there is probably going to recommend you keep that thing in the home for a couple of weeks, let it run, get a good 100 hours on it, and it's especially true on a plasma.
Yeah,
which is the common
the common wisdom, and it's correct, I think. And I always recommend, if you have a test pattern generator, and not a lot of consumers do, but if you do, one good way to do it, the way we do it in our studio for reviews, is we put up a 50% full gray field that covers the entire screen with the same gray, 50% of full white, and just leave it go for a couple days. And or over the weekend or something, and that's fine. Most people don't have a test pattern generator, and so what I recommend in that case is just keep your set tuned mostly to high-def channels that transmit full 16:9 images. You don't want a lot of letterboxed movies on the screen. You don't want a lot of 4:3 material on the screen, which will age the phosphors unevenly. So just make sure it's a full 16:9 field, moving images, not static images, unless it's just a gray field, and then you're good to go.
Yeah, the other thing is, the other good thing about doing that, and now from my experience being a old maintenance guy, is most of the time, if something is going to fail, it's going to fail in the first 100 hours anyway. Yep. Because it's a cold solder joint, or it's something that you're going to want to find anyway and get it replaced or fixed. Right. So there's multiple reasons to burn stuff in.
Right, exactly. Ed DV asks, why don't TV manufacturers ship with a calibrated default mode? Well, some of them do.
Absolutely. In fact, most of your televisions now, you're going to find in there a movie mode. You're going to find you're going to find a movie mode. I doubt that it will be set to movie mode when you take it out of the box. It won't. No.
It'll be set to dynamic or vivid or something horrible.
It will be set to arc welder on your eyes.
Yes, that's right. The future's so bright, I think I need shades.
Exactly. But if you go digging around in there, you're going to find there's something that's going to be closer to a movie mode, or to the 6500 we've been talking about. And there's multiple presets in there. The reason they can't just do it perfect in the factory, though, is because they just don't know where this thing's going to end up.
Right.
In your lighting conditions. And they also
are going to affect, by the way, just to make sure that everyone understands, the lighting conditions in your room are going to affect how the calibration ends up. And the manufacturer can't possibly know what your room is like or what your conditions are like, so they can't possibly set it up perfectly for your room. I did want to mention quickly that there, in some TVs, including some Panasonics and LGs, not sure who else, there is also a THX mode, which is supposed to be pretty darn close. And according to what I've experienced in my measurements of these sets, it does get reasonably close. But again, it can't be perfect because they don't know what your room is.
That's absolutely correct. It's what it is it's an attempt to do it in the factory, and it's probably based on some preset ambient lighting condition, probably close to dark. And then the backlight is set appropriately if it's a backlight, you know, LCD type display. But yeah, they're taking a guess at where that thing is going to end up, and it's good. It's a good step in the right direction. The whole capability with the ISF day and night modes is fantastic, though. Those are actual memories that you can go in and set up and do this advanced calibration, and then you can actually lock them down. So once those get done, then this typical application, like I have a 15-year-old daughter who likes things in torch mode. You know,
wow.
Games, you know, contrast, brightness, max, vivid,
max,
you know, Xbox 360, PS3 stuff. Well, I don't like that.
Right.
So
right.
I like to have a quick way. Okay, you go do that, and then I want to watch a movie. I can click a button, and I'm back into a nice D65, really good dynamic range.
Comfortable mode.
Very comfortable. Very easy. The way I kind of put it to people is, you know, I can remember I used to fall asleep in movies. and a lot of it, especially the ones my wife makes me watch, but a lot of it is because it's eye strain, you know, and you just get tired.
Yep,
and
exactly
if that's happening, a calibration will fix you.
Now, there's one other question I wanted to ask, and we're just about out of time, and that is calibrating 3D. Now we have these TVs that are 3D capable. You know, they show 3D images. You have to wear the glasses and all that stuff. Some people like them. Some people hate them. But if you like it and you want it in your house, what are the differences, and how do you go about calibrating the 3D mode, which I would wager you have to calibrate separately from 2D. They're two different things.
Well, actually, the calibration process is essentially the same, but the difference is you gotta remember that those funky glasses are in the light path,
right?
Or in the path of your eye to the screen. So you know, you got to figure out a way to get the meter to take a reading for the grayscale through the glasses, and then you've also got to have the glasses on when you're setting things like brightness, contrast, color, tint, sharpness. And, you know, we got some tech tips on how to do it. It's really not that complicated. And the TVs that I have done and seen it done on, they actually have a discrete memory for that 3D. So when the TV goes into 3D, those settings get saved in that memory that is tied to the 3D. You know, when the TV sees 3D content and goes into the 3D mode, it will pull that memory in.
And that's the problem, though, because other than Joe Kane, who was on the show a week or two ago, who has developed test patterns in 3D to be played from the Video Forge test pattern generator that we were talking about earlier, there aren't any 3D test patterns. There aren't any 3D setup discs on Blu-ray yet. I know there are several people working on them, but they're not available yet. And so if you cannot send a test pattern in 3D to the TV to tell it to go into 3D mode, you're going to have a little bit of a problem in that regard.
And that's exactly why I think the Video Forge, that the product is doing so well, is it does. I mean, it literally has controls there where you can set it up for any flavor of 3D, and it will turn that TV on into its 3D mode, and it will render 3D test patterns, and it will render every test pattern it has on it in 3D. So there's no special, special setup required. Then and the reason I mentioned the Video Forge is it's a fairly low-cost generator for a professional tool.
I was going to ask how much that is. The Video EQ is like $1,200, right? That's not cheap. But what about the Video Forge? It's
a little over $2,000. It's I think $2,500 with the Joe Kane test patterns built into it. And but if you want to quantify that, you go up to our next model, and we're up in the $4,000 to $5,000 range, and you go above that, you're up in 10 and above. So now you're getting into lab instruments. So for field service, it makes a really good choice. As a good digital generator that also does 3D.
Yeah, it really is an excellent tool for those well-heeled consumers who want to try it out, and certainly for professional calibrators, which if you don't want to get into all of this stuff and take training courses from ISF or THX or so on, it really might be better for many consumers to, if they want to get the very best out of the TV or the projector that they can, to hire a professional calibrator who has gone through those training sessions and who has invested in those hardware tools.
And he can be the educator, and that's what they're there for. Is they're running into this every day. And so they are a very good, even if you only did it the one time, like say you had an interest and you're saying, well, do I really want to burn 3 Sundays trying to figure all this stuff out? Or should I maybe hire a guy to come in? I can learn a whole lot, and I can get my TV dialed in, and then maybe from there I can kind of explore further. I think that might be a better way to go. So I agree with you.
Yeah. Unfortunately, we've run out of time, and this has been a fascinating discussion. I hope you'll come back sometime and continue our geek out on TV calibration, will you?
I would love to. It was very much appreciated. I enjoyed it a lot, Scott. I appreciate being invited.
Thank you so much, Jeff. Really appreciate it.
Take care.
You can look up SpectraCal at SpectraCal.com and see all of the latest stuff that they're doing. My online homes, of course, are ultimateavmag.com and hometheater.com. You can email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott. Those of you who are listening to this podcast before June 12th should know that I'm subbing for Leo Laporte on The Tech Guy Show this Sunday, June the 12th, from 11 a.m. to 2 p.m. Pacific Time. You can watch live at live.twit.tv, or tune into your local radio station and hear the show with me talking about home theater for 3 whole hours. Should be a blast. Hope you'll join me. Next week, my guest geek is scheduled to be Chris Conacher, an expert in computer audio and founder of ComputerAudiophile.com. I don't know that much about this particular area of audiophilia, so I'm really looking forward to talking to him, and I sure hope you'll join me. Until then, geek out.